You cannot touch it, bottle it, or step outside of it, yet nothing in your life happens without it. This is time, the invisible rhythm behind every heartbeat, every memory, every moment you call now. Last episode we learned the fourth dimension is a spatial direction, not time. This episode is different. We're going after time itself, what it is, how physics defines it, and why your clock is lying to you more often than you think. No heavy math, just clear explanations and analogies. Let's dive in. First, a quick callback. In the fourth dimension video, we said time is not the fourth spatial dimension. You can move left or right in space. You cannot choose to move into yesterday. Time isn't a direction you can point at like breadth or depth. It's something else entirely. In daily life, time feels simple. The clock ticks forward. Calendars flip. You age. We schedule meetings and count birthdays. This everyday time is about sequence. Before, during, after. Events happen in order. That feeling is real, but it hides a deeper story physics had to uncover for centuries. Isaac Newton pictured time as absolute. One universal clock ticking everywhere at the same rate, independent of motion or location. Whether you stood still or raced on a ship, Newton's time flowed uniformly across the universe. The same now for everyone. Albert Einstein shattered that picture. He showed there's no single universal clock. Time depends on how you move and where you are. Two perfectly accurate watches can disagree and both be right. Time isn't a fixed backdrop. It's part of the physics of each observer. Einstein merged space and time into one fabric, spacetime. You don't just have a position in space, you have a position in time too. Every event is a point in 4 coordinates. Moving through space affects how you move through time, and gravity curves the whole fabric. This leads to time dilation. Move faster, and your clock runs slower compared to someone at rest. It's not an illusion, it's measured fact. Atomic clocks on airplanes arrive showing less elapsed time than clocks on the ground. Speed literally steals ticks from your future. Gravity does the same thing. Clocks run slower deeper in a gravitational field. Near Earth's surface, time passes slightly slower than on a satellite in orbit. The stronger gravity is, the more time stretches. Mass doesn't just pull objects, it warps the flow of time. So why does time feel like it only goes forward? One deep answer involves entropy, disorder. The universe tends toward messier states. Broken eggs don't unbreak. Heat spreads out. This thermodynamic arrow gives us a practical direction for time, even when the underlying equations could run backward. Your brain also builds the arrow, memory locks the past, and leaves the future open. We experience time as a flow because consciousness tracks change, comparing what was to what is. The present is the thin edge where prediction meets record. Some physicists picture a block universe, past, present, and future all equally real, like frames in a film strip laid end to end. In that view, tomorrow already exists on the timeline, we just haven't reached it yet. It challenges the feeling that only now is special. How do we measure time so precisely? Atomic clocks count vibrations of atoms, billions of ticks per second. GPS satellites carry atomic clocks that must account for both speed and gravity. Without Einstein's corrections, your navigation would drift kilometers every day. That's why time isn't abstract philosophy. Your phone's maps, financial networks, and space missions depend on understanding relativity. Time is woven into the technology you use every morning. Get the physics wrong, and modern civilization literally loses its way. Your felt time doesn't match clock time. Boredom stretches minutes. Flow states compress hours. Fear slows the world. Routine accelerates it. Physics gives the objective measure. Psychology gives the experience. Both are real in different senses. Big questions remain. What happened at the beginning of time, if there was one? Why do we remember the past but not the future? Quantum gravity may change the story again. Time might emerge from something deeper, not fundamental at all. Remember, space-time combines space and time in physics, but that doesn't make time a spatial dimension you can walk into. The fourth spatial dimension from episode 1 is breadth, perpendicular to depth. Time is a partner in the fabric, not a direction you can point your finger along. Time is stranger than any wall clock suggests. It stretches, curves, and may not even be fundamental. We live inside it every second, yet we're still learning what it is. Keep exploring, and tell us, do you think the future already exists, or is it genuinely open? If this shifted how you see the clock, subscribe to Cosmic Ladder. We'll keep climbing the next rung together. Thanks for watching.